All right, this is again just a review from what we did last week. Looking at this model, make sure you use the question to tell you which angle to focus on. And that helps you with what is your opposite adjacent hypotenuse. Example, sine of pi over 6 means pi over 6, which I look through here, there's pi over 6. That's my angle that gives me my opposite adjacent hypotenuse. Your hypotenuse does not change, but your opposite and adjacent do based on which angle we're looking at. Sine being our opposite side over our hypotenuse. So on pi over 6, your answer should have been 1/2, 1 over 2. Any questions on that? Okay, so let's go ahead and just get the rest of the answers up here. Cosine is adjacent over hypotenuse, and that would be 45 degrees. It doesn't matter, they're both 45 degrees. So my adjacent side is 1. My hypotenuse is 2. You are not allowed to leave that unsimplified. So make sure you rationalize. When I rationalize, I would multiply top and bottom by that radical, and this would rationalize to the square root of 2 over 2. So if you were at 1 over the square root of 2, you have the correct setup. You just need to finish the problem. Okay. Tangent of 30. So again, we're going to go back to here. I already have it marked correctly. Tangent is going to be our opposite over adjacent. Same conversation. Opposite is 1. Adjacent is square root of 3. Rationalize. So I get the square root of 3 over 3. Cosecant is the reciprocal, and that's where we are now responsible for going back and looking at what these match with. Cosecant is the reciprocal of sine. So sine is opposite over hypotenuse, which means cosecant is going to be our hypotenuse over opposite. And pi over 4 is our reference angle here. So hypotenuse over opposite would be square root of 2 over 1. It's fine if you leave it like that. However, anything over 1, we don't have to write the over 1 part of it. So you would normally see the answer as just the square root of 2. Secant is your reciprocal of cosine, which makes it hypotenuse over adjacent. 60 degrees becomes our reference angle. So now we're looking here. That would make my opposite and adjacent switch. Here's my opposite. Here's my adjacent. Oops, adjacent. So my hypotenuse is 2. My adjacent is 1 from the 60 degrees, which would simplify down to 2. And finally, our cotangent of pi over 3. So sticking with the same angle as our reference angle, there's your pi over 3. Cotangent is the reciprocal of tangent. So tangent is opposite over adjacent. Turn that upside down. Adjacent over opposite of pi over 3. So adjacent over opposite gives us the same exact thing, actually. Rationalize. Okay. Sometimes I have people asking me, like, what do I need to show? So looking at, like, you guys see the work that I have up there for like cosine tangent and cotangent? Do you need to show that? No. And eventually I'd encourage you not to. Let's speed up the process. If you see that you're about to write down 1 over the square root of 3 and you know that that rationalizes to square root of 3 over 3, you just write that down. That's where we're headed with this. And you'll see those enough. They don't change. Next week, when we get introduced to that big thing called the unit circle, which is what we're laying all this foundation for, all of those numbers are this. You just see those same numbers over and over and over, and you will get so used to it that instead of writing this down and rationalizing and getting this, you just write down square root of 3 over 3. Okay? Okay. Today, we are going to not do that. We are talking about, and I understand why it is in this section, it's going to feel a little kind of disjointed and random, but it's these formulas for arc length and the area of a sector. The biggest thing about these is that they come from the fact that we now know radians. You actually may have been introduced to the idea and the formulas for arc length and area of a sector back in geometry. However, in geometry, you didn't know what this thing was called a radian. And so these formulas actually looked a lot more complex because within the formula, it had to do the converting to your angle being in radians without you knowing it. Well, now our formulas don't look complex because we know how to find an angle measure in radians. So it's going to be a lot more straightforward today. We have 2 different concepts. One is the length of an arc. Okay, What you see highlighted in red is what's called an arc, and it is just a piece of the circumference of your circle. Or if I were to like wrap a bendy measuring stick around the circle, measuring how long that little piece is, okay? That's an arc. It is related to how wide that angle, it's called a central angle, how wide that central angle has to open up to cover that arc. And your formula is very, very simple. It looks like this. And I don't know why they use the letter S to represent arc length. That seems very random to me, but it is S is your arc length is going to equal whatever the length of the radius is times the measure of that central angle, which is here. But I will tell you right now, this is the part that is going to catch us, is that the central angle has to be done in radians. And for whatever reason, most of these problems are handed to us in degrees. So job number one is going to be to always convert our angle to radians and then put it into our formula. Rarely do they hand us it in radians. They can, just not very often. So we'll start by most of these converting our angle to radians and then putting it into that formula. Or maybe they tell us what this is and we have to solve for R, etc. Okay, there's your arc length formula. So putting that into play, here's an example question for you. Find the length of a circular arc. And the question goes like this. A circle has a radius of 6 inches. Find the length of the arc, and they use a lot of these words. Intercepted, you'll also see the phrase subtended. Don't get caught up on those vocab words. It's all asking you to do the same thing. Is once you've identified that it's arc length, you are finding that formula, S equals R theta. By the central angle of 45 degrees, express arc length in terms of pi, and then round your answer to do 2 decimal places. A couple things, just vocab words again. Intercepted or subtended just means that it has that central angle. That's what's the angle that's coming out and breaking into your circle. The other thing is express the arc length in terms of pi can also be written as keep your answer exact, because we don't have to round when we keep that symbol in there. That means don't type pi into your calculator, leave it as part of your answer, like 5 pi, okay? So a couple things. First of all, the fact that they said the length of the arc means that we are focusing on this formula right here. And actually, instead of S, I'm going to put arc length. I'm just going to write out the words there. You can put S. Arc length equals our radius times theta. And then identifying the information for ourselves here. They do tell us the radius is 6. And they tell us that theta is 45, unfortunately 45 degrees. And that's where we have to start this problem, is we must convert. Must always be in radians. So we're going to start with, and this is why we learned how to convert these, start with converting our 45 degrees, okay? I'm going to pause here for a second and you think about, okay, I know that fraction has a 180 and it has a pi in it. If I'm converting from degrees to radians, you decide. I'll tell you if you're correct here. Would you multiply by 180 over pi, or would you multiply by pi over 180? Just a reminder that that question right there is definitely one that we are responsible for. That is not a formula that will be handed to us. And so converting from degrees to radians, if you forget, think about the labels. I want the degrees to cancel, which means I need the 180 in the bottom. So you should have picked to multiply by pi over 180, that we keep that pi in the numerator. And right now I'm simplifying the fraction 45 over 180, okay? Any questions on that? And if I'm remembering correctly, I believe that simplifies into 1/4, okay, or pi over 4 would be our theta. So that means that theta up here will be pi over 4 because that is in radians, and theta must be in radians for our formula. The number one mistake people are going to put is just putting the 45 degrees into the formula without converting. easy to do. You see numbers, you put them in the formula. We make that mistake, okay? All right, so our arc length then, we can now put in these numbers. Radius was 6. We now know that theta is pi over 4. Okay, it said to express your arc length in terms of pi. That means don't type in pi. That's what express in terms of pi means. So what am I typing in? I'm typing in 6 divided by 4 and simplifying that fraction. Or 6 over 4 would simplify to 3 over 2. So this would simplify down to 3 pi over 2 inches. That is in terms of pi. That's that first part, in terms of pi. Just means don't type pi in, keep it as a symbol. The second part said round your answer to 2 decimal places. So now I'm going to grab my calculator and I'm going to type in 3 times pi divided by 2. And you guys are going to say, I think it's like 4 point something. I'm guessing. 4.7. Is that 2 decimal places? 4.71. I'm just following directions up here. Normally we've been going around the nearest 10th, but they said on this one 2 decimal places. Okay. Questions for me? So remember, in terms of pi could also be asked as exact. It just means that I'm not rounding something, okay, that I should still have a pi symbol in my answer. All right, some variations on that formula. Find the measure of the central angle. So this time our answer at the end is going to be our central angle. This one is huge, 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 understanding what theta is in our formula. Find the central angle created by an arc length of 10 centimeters. So they tell me that the arc length, which in our formula is S, equals 10 centimeters. And the radius equals 8. And the question is, what is theta? So as we put those into the correct places in our formula, we would have 10 equals 8 times theta. And theta becomes our variable in this one. Solve for theta. Okay, and this is where we are going to run into issues. Not necessarily on this part of it, but 10 over 8, find 10 over 8, or simplify both divisible by 2, 5 over 4. If I were to put a label after that, it's 5 over 4 what? It's our angle theta. Theta is in what units? Radians. 5 over 4 radians. Radians. So when the question was, give your answer in radians, isn't that your answer in radians? 5 over 4, and that bothers people a lot for whatever reason. Don't overthink it. I get that it doesn't have a pi in it. It doesn't have to have a pi in it, right? Radians don't have to. A lot of times they do. They don't have to. That is your first answer. That is your answer in radians. You're done. 5/4. Then follow your converting, because it did also ask us to find our answer in degrees. So now convert to degrees to answer that part of it. Okay, so we right now have an angle of 5 over 4. Converting to degrees, we use the fraction 180 over pi. Can I cross off a pi in this one? No, which means I'm going to type it in and get an ugly answer, and that's okay. So type in 5 over 4 times 180 divided by pi. It did not tell us what to round to on us, did it? I'm going to give you a little preview. This question on your unit objective quiz on Thursday says 3 decimal places. Way randomly out of the blue. So let's just do that on our assignment, or on our notes here too. Okay, so 3 decimal places. Who's got this for me? Okay, so that is 3 decimal places actually, because the 9 would have rounded up, right? Okay. Degrees. There is your second answer. People want to put a pi here, like out of the blue to convert. It didn't have a pi. It doesn't need a pi. People want a pi here. That is just your answer in radians, and it seems like it's too easy, and I understand that. It's not. Don't do too much work. When you solve for theta, that is your answer in radians, and it probably won't have a pi. Questions? This one right here. If for whatever reason everyone always misses this, go back and look at this. Okay? All right, second formula. Area of a sector. Area is just what it's saying, area. So now I'm looking at that whole slice of pizza, okay? Filled in, what is that shaded region? What is that fraction of the area of the circle that we are looking at? Formula on this one, a little bit more complex. Area equals 1/2 times our radius squared times our central angle, which again is in radians. So typically we start with converting our angle to radians because they'll always hand it to us in degrees. And or if they ask us to solve for theta, our answer is in radians. All right, does anyone still need this page? Okay. So seeing a couple of variations of the types of problems we can have involving the area of a sector questions. First example, this one's a pretty straightforward one. Find the area of the sector with a central angle of 3 radians in a circle with a radius of 12. So the information they give us, first of all, they say find the area of a sector, which means we're focusing on this formula that we just saw on the last page. They say we've got a central angle of 3 radians. And again, don't mess with it. They tell us that our central angle, which is called theta, is 3 and just 3. Okay, so it's just a 3. Means it opens wide enough for 3 radii, right? That's what a radian is. And a circle radius of 12, put that information in here, solve for A. And this one's pretty cut and dry and is going to be a nice number and that you are going to tell me. One half times 144 times 3. What is it? 216? We're talking area, so you would see my label as meters squared. Questions? That was very straightforward, right? Didn't have to do any converting because it started in radians, and that's exactly what we need this to be. Okay. Let's see a little bit of some variations here. This time they tell us the area, so they start with the area of a sector. Of a circle with radius 22 has an area of 310. Find the central angle of the sector, give your answer in radians and degrees. So again, as we start our formula here, they tell us that the radius is 22. They tell us that our area is 310. And they say find this, right? Find theta. So that's going to stay as our variable as we set this one up. Okay, we might need to do a little bit of a get to know our calculator moment here because there's several different ways we could attack this. I would probably start by just typing in my calculator 22 squared and then dividing by 2 or multiplying by 1/2. Let's just kind of do this step by step here. 242. I was gonna say, was it 484? 242. Okay, and then again, I'm going to keep this nice here, so I'm going to divide by 242 on both sides. Just simplify this fraction, okay? And now my label. What? 155 over 121 Radians, right? That is our answer in radians. So I had space over here that asked for my answer in radians. I would write 155 over 121. Stop, right? That's all there is to that answer. That is your first answer. That is theta in radians. It did ask us to convert again to degrees. So now I'm going to convert my radians answer to degrees. I don't change the number, right? The number is still 155 over 121. And my conversion to degrees is to multiply by 180 over pi. And if I have a pi in there, I'm going to go ahead and type it in because I don't have a pi to cross it off with. And that's okay. It gives me an ugly decimal, which again, I don't know what it rounds to. Let's round to 3 decimal places here. $73.395. How are we doing? Good? Anyone still need this page? All right, we have one last one to look at, and that is because of how radius is in this equation, just looking at kind of one more option of how you could see this. Our last example today says the area of a circle that has a central angle of 45 degrees has an area of 39.3 meters squared. Find the radius, okay? So information that's given to us is that our central angle is 45, and very important that we recognize 45 degrees. And they also tell us that the area of that sector is 39.3. The question is to find the radius. And this is what I've said, as advertised most of the time, we have to start by converting this, right? To put it into our equation, we need it to be in radians, and it is currently in degrees. Practice, practice, practice the correct fraction for converting, which way we're going. Does the pi go on the top or the bottom? Where does that 180 go? Again, if you need to, use the labels to kind of help you remember. So as always, I'm going to have a pi in the top, and now I'm just simplifying 45 over 180, which I think we did earlier already, right? 1/4 pi over 4. So theta for our problem is going to be pi over 4. And then this one gets just a little bit ugly here. So our area is 39.3. So let's talk about how I can do this on my calculator. The whole pi over 4 thing is always a little bit tricky. So if it was me, this is what I would be doing on my calculator. I would multiply by 2 to get that 1/2 out of there, okay? Leave that on your calculator. I would actually also multiply by 4 to get that 4 out of there. And then I got to get rid of the pi is the last thing I have right now, right? Because right now all I have left is r squared times pi. So then the last thing I do is divide by pi. Whatever number I have in my calculator right now, I'm going to divide it by pi. Are we okay with that? No. No, no, okay, let's back that up. Let me show mine a little less. It's just the whole moving the pi over 4 thing that's a little bit ugly here, so just be cautious with that. Let me grab my calculator. I'll do step by step and actually write down my numbers here. The first thing I do is I get rid of the 1/2 by multiplying by 2, which is 78.6. Okay. To be careful about like the just dividing by pi over 4, if you carefully type it in your calculator, you can do that. I just tend to do it step by step on here. So then I would maybe multiply by 4 to get the 4 out of the bottom there. So now times 4, I'm looking at 314.4. And then lastly, dividing that by pi. Which now that I'm typing in divide by pi, I'm going to have to round here. Okay, now are we okay? Is that making sense-ish? Okay, now you typed it in differently and you still got to this point at 100.07, whatever. Then you typed it in, great, it'll work, okay? You're fine. I just did it one number at a time. If you divided by and you typed in like pi over 4 all together, great, that works, as long as you're here. Finish up here, so square root to get rid of that r squared. And actually, when you type this in your calculator, it comes out pretty nice, rounds to just 10. Okay, that's the last little part that we hadn't seen before, is just one more step of solving on this one. And we find out our radius is 10 meters. Some people get concerned. I will always try to put labels on there. It is not something that is a big focus of this. If you can get to the number 10, you're good. But just kind of remembering what we just found, like, is always important, I think. Not going to be a point or anything off if you forget your label. Questions? All right. We are going to get a little bit of time here to get started on our worksheet. Again, a worksheet today. Mm-hmm. Yeah.